Hey everyone, I'm Raghav and this is my data structure Fundamentals-2 Self-Con 2 Assignment 9, and today I'm going to discuss about the following two questions. Question first is how to delete the kth node from the beginning in a singly and a doubly linked list, and question second is explain real-time applications of SAC. So coming to question 1, how to delete kth node from beginning in a singly and a doubly linked list. So to delete the kth node from the beginning in a singly linked list, what I would do is, if my kth node is 1, that means I want to delete the first element. Then what will I do is, I'll just say that I'll, uh, I'll just create a new node temp, and I will just say that temp is equals to head, and then I'll just say head is equals to head of next, and I will just say delete temp. So that will remove my case in where k is equals to 1, and then I will just say if uh, like else my if k is not 1, I want to delete fourth element from the single linked list. Then what will I do is, I'll just create two new nodes, current and previous. I'll just say current is equals to head and previous is equals to null. Then I'll just create a while loop while k is greater than 0 and current node is not equal to null pointer. My previous node will be equal to the current node, and current node will move by one step. That will be current is equals to current of next, and then I'll just subtract k by 1 point, and then uh, I'll just exiting the loop. I'll just check if my current is equals to null pointer. Then I'll just say there are not enough element inside the linked list. Otherwise, I'll just do is, I'll just say previous of next is equals to current of next, and current of next is equals to null pointer, and delete my current node. So that will remove my kth node from the beginning in singly linked list. But if I want to do this operation in doubly linked list, then what will I do is, suppose if k is equals to 1, that means I want to delete the first element in a doubly linked list. Then what will I do is, I'll just create a new node temp and assign it to the head pointer. I'll move my head by one step. I'll just say that my head of previous is equals to null. I'll remove the connection of head pointer and the temp node, and then I'll just say uh, delete temp. So that will solve the case if k is equals to 1. That means I'll solve the case for if the node is first node. Otherwise, suppose I want to delete the fourth element again, then I'll just create a new node saying current node, and I'll just say current is equals to head, and I'll move my current to by one step until my k is greater than 0 and my current is not equal to null pointer, and I'll just subtract my k by 1 point inside that while loop, and then afterwards if my I'll just write a case like if my current is equals to null pointer, that means uh, there are not enough elements and I will return. Otherwise, I'll just say that my current of previous of next is equals to current of next, and my current of next of previous is equals to current of previous, and I'll just move the connection of current of next and current of previous by saying current of next is equals to null and current of previous is equals to null, and then I will just delete my current node. So that will remove my kth node from beginning in a doubly linked list. So coming to the second question, uh, real-time applications of SAC. So real-time applications of SACs can be used in undo and redo operations. So like in Microsoft Paint, if I want to draw something and I accidentally misdrew it, then I could just say Control Z to undo it and Control Y to redo it. So that's operation where stacks is used. So other case like in browser history, stacks are used. Like if I want to go to the previous browser page, I would just click on this arrow, and it will take me to the previous page that I was viewing before this current assignment. And that also where stacks are used in viewing browser history. Browser history stores the data. And next would be backtracking algorithms like depth first search. If I want to go to the previous node that I am currently on, then I could just move to the previous node. So backtracking algorithms also use stack. Other thing that would be the function call stacks. Yeah, in programming, a stack is often used to manage function calls. When we call a function, uh, its local variables and pointers are stored in function call stack, and when the function is ended or removed, then when the function is returned, then all the elements or data and pointers that are of that function will be popped out of the stack. So this mechanism allows efficient memory management in programming. And other case in games also, we can use stacks. Like there are famous games like Tower of Hanoi, which uses operations of stacks. So these are the real-time applications of stack. So that's all for this video. Thank you so much.